Today's lesson is our second lecture in the dual credit physics lab, and we're talking about the importance of outliers. So you may remember that we discussed outliers in other science classes that I've had with you. We are actually revisiting some of those conversations like the radioactivity and such. But one of the reasons I bring this up is because students typically in physics labs tend to get rid of the points that don't make sense to them. Sometimes these points that don't make sense have meaning and are important for how you answer the questions in the lab. So it's always good to consider them and make sure that they are truly outliers before you discard any points. Okay, so let's review what an outlier is. And one of the definitions that you get, this one comes from Wolfram, which we use sometimes, the website. It's a data point that is distinctly separate from the rest of the data. And so if we're looking at a graph, then you can see that there's a difference in the line of best fit. So for example, the one to your left here, you see with the outlier that it's sloped a little more downwards. If you take the outlier out, it's sloped a little more upwards and it better fits the points. And so we've gotten into the practice where we just take out those points that don't fit and say, oh, that's what's going to get me a better average, better slope, maybe closer to the right velocity or closer to the right amount of force. So you may remember from an earlier discussion that we had last year about the different types of statistics and all those things that we talked about the interquartile range. So just to remind you, it is the mid-spread of a statistical dispersion, and it's what we call the middle 50%. So if you're looking at this diagram, you can see where 50% is in that brighter blue, and I'm looking in the middle there, and that very center is our median, and that range is the interquartile range. And it falls between the 25th and 75th percentiles of data. So if there exists a point that's 1.5 times more than this range, above or below 25 or 75% of the data, that is an outlier. And many of the values that you guys find in lab and you discard, they are not more than that range. And so you're discarding points that you need to keep, you shouldn't get rid of. One of the places where we used this information with outliers was when we talked about radioactivity and the band of nuclear stability. And remember, this was a curved line and it had two slopes. So at the very bottom of it, there's a line that we look at where the ratio of neutrons to protons is 1.1. And then toward the top of it, as you get closer to lead and some of the heavier elements, that ratio was 1.5 to 1. And we found that when you depart too far from that 1 to 1 or 1.5 to 1, then the isotope is radioactive. And it turns out that all of those elements, the ones that land above the band of stability, those are your upper outliers. And the ones that land below the band of stability, those are your lower outliers. Every single one of those outliers are radioactive elements. And so we had the beta decay that decayed down to the line, and we had the positron decay that decayed up to the line. Well, you can't really rule those radioactive elements out as not important, but you can rule them out as being unstable. And so that's what we did. That's how we used that graph in that course. In physics, it's often the case that measurements are intended to be linear. So students go into the lab knowing this information, and you just kind of fudge things so that it makes sense the way you think it should. Well, if you find a recording, say, from the motion sensor that departs from your expectations, it's just, oh, I'll just get rid of that one with very little thought. But what's to say that that one point out of your 4 or 5 points that you've taken is not the right one? Maybe you've made a mistake and mismeasured the others. Well, what will help you with this is to consider additional trials. I know everybody wants to be finished with lab quickly, but the more trials, you increase your sample size, as well as after that, you perform a statistical analysis to prove that a point in question truly falls outside 1.5 times the interquartile range. And that's what we're going to do in this lesson. We're going to look at data sets, and we're going to actually find those quartiles and remember how we did that in the past and see if outliers truly fall in that range, if they can be discarded or not.